Hello, everybody. So we're going to be doing day 4 a little bit differently. I'm going to try out a new program. If it works, it works. And if it doesn't, well, we can scrap this. But for day 4, I'm going to be starting with the proportional and not proportional relationships. Okay. Now, this, you guys are given a whole bunch of tables. Okay, look pretty similar to this. Not exactly like this because this is only an example. But you should have something pretty similar to number of hours given and how much money a person is making. Okay, you can see here that for every 1 hour, or for 1 hour, this person makes $10. 2 hours, they make 20. 3 hours, they make 30, and so on and so forth. You guys can probably already see a pattern. And for proportional relationships, that's exactly what you're looking for, a pattern. But the way that you can 100% guarantee that there is a pattern is if every single ratio, when simplified, is the same. Then you have something that's proportional. Okay, now for ratios. Okay, I've gone ahead and I've filled these in beforehand. And all I'm doing for my ratios is I'm taking my top number here and placing it on top of my other number. Okay, as long as you keep the same number on top and on bottom, it won't really matter. Okay, now for my ratio, right here, I put this number up top, on top, and this number right here as my denominator. Okay, I can't simplify this anymore. If I simplify, or yeah, there's just no more. It's just going to be 1 over 10. So I'm going to go on to the next one. Now again, top number up here goes to the numerator. This number is going to go to the denominator. I can simplify this. If I divide my top and my bottom by 2, this is going to change into 1 over 10. Well, if we already got 2 that are matching like that, chances are we're looking at a proportional relationship, especially if we could already find a pattern. Now this one, I've got 3 over 30. Okay, I can divide my top and my bottom by 3, so I'm going to simplify that. And that is going to go to 1 over 10. Okay, same thing over here. I can divide my top and my bottom by 4. If I do that, my ratio is exactly the same. All right, so every single one of these ratios is 1 over 10, so this is a proportional relationship. Over here, I have these guys. I've placed the same numbers in the numerator and the same numbers in the denominator. I get 1 over 11 here, 2 over 19 right here. This doesn't simplify, this doesn't simplify. Right here, I got 3 over 30, okay, which I simplified down to 1 over 10. And then I got 4 over 37. I can't make these any smaller. They don't simplify anymore. So since none of these match, and I don't have a repeating matching ratio, this is not proportional. Okay. You're given some empty spaces to fill in. So on yours, this row would be blank. And you have to write whether something is proportional or not proportional. I have an example of a proportional relationship right here. Now, proportional relationships, they follow a pattern. Right here, 1 hour of work gets $6 of pay. Okay, and then it goes up by another 6. Just how the one up here went up by 10, okay, it has to follow a pattern. Okay, so for 2 hours, you get 12. 3 hours, you get 18. 4 hours, you get 24 hours. Or not 24 hours, $24. Non-proportional ones, they do not follow a pattern. 1 hour, it goes up by 4. After 2 hours, well, it only went up by 2. After 3 hours, it went up by 6. And then for the 4 hour, this dude got like a 38 for or a $32 pay raise. There's no pattern, nothing that can be observed. And if I were to put these in ratios, I wouldn't see anything in common, except for maybe 2 of them. But I wouldn't have the same repeating one all across the board. All right, I'm gonna go on to our next one. Okay, this is gonna be your rule of 4. Okay, now this is the one that's supposed to be create a table, graph, expression, equation, and then you're supposed to fill it in with your words. Okay, now I have my graph really blown up on here so you guys can see. All right, and I'm gonna be working to the left and to the right of it so that you guys can see what we're supposed to do here. All right, but I've got 4 points. 1 is 0, 0. 1 is 4, 1. Remember, you read these right and up. 1 is 8, 2. And then I have 12. Doesn't make it all the way up to 4. It's about halfway, so that's 3. So 12, 3. All right, so let's make a table from that. Okay, I'm going to put T for table right here. I'm going to put X, line under it, and Y, and then a line going through. Okay, so my first point is 0, 0. X is 0, Y is 0. That's easy enough. Here I go over 4, so my X is 4. I go up by 1, so my Y is 1. Okay, over here my X is 8, and my Y is 2. Moving over here, X is 12, and my Y is 3. So those are my 4 points. Okay, so my table is done. I gotta make an expression now. Now, making an expression, not gonna lie, it can be kind of difficult. But if I have a graph, there's a way that I can kind of cheat it. Okay, so whenever you make an expression from a graph, especially an XY graph like this, okay, everything's always going to equal Y. Okay, and then you're typically going to have an X. Okay, but what we're missing is the number that goes in front of the X. Now, how we're going to find that, since we have a graph all ready to go, is we're going to use what's called rise over run. All right, so I have rise over run. And quite literally, I'm going to check on my points how far it's rising and how far it's ran. So I have 1 point right here, and I want to see the change in between these 2 points. Okay, so I'm going to check the rise. This one goes up to 1. Yeah, so the change from here to here, it goes up by 1. Now I'm going to see how far it's ran from point to point. Now from here to here, it's gone over 4. All right, now this right here, something I haven't gone over with you guys, but it's called a slope. Rise over run will get you what your slope is, and your slope always goes in front of your X. Okay, that'll be your equation. Now, rise over run will work on any point. If I look here, I'm at 1. If I check here, it goes up by 1. And it's gone over by 4. So my rise and run here is 1 over 4. Same thing's going to happen here. If you look at this, this is 2. This is at 0.3. So the rise, it's risen by 1. And it's gone over by 4. Okay. Now, the last thing that you have to do is use your words. Okay, what is the constant rate of proportionality? All you have to do is answer that question. Okay, the constant rate of proportionality is for every 4 x's, the graph goes up by 1. Okay, and it's as simple as that. Now, yours might not go over exactly 4, okay, but it should be pretty close to that. You should not be getting anything that's like, I don't know, it goes over by 1,000,000 and then it goes up by 1. If you did, send me a message. That's kind of scary. Okay. You guys